All right, folks, here we go. We are continuing our discussion of Chapter 8, Section 2, which covers the Pythagorean theorem. And today we are covering the idea of a Pythagorean triple. So this is a vocabulary word for those of you that remember that, in fact, when we return in person, there will be vocabulary quizzes. The Pythagorean triple is a vocabulary word. It is defined as a set of three positive integers which could represent the side lengths of a right triangle. So a couple of things to note in that definition. One, it is three positive integers. That means decimals and fractions are a no-go. They have to be integers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, those numbers. Okay, not the partial numbers. So if it's a fraction or a decimal, it is not a Pythagorean triple automatically. Okay. 2, it has to, these would represent the side lengths of a right triangle, which means the numbers would have to satisfy the Pythagorean theorem, which is why this is being discussed in this section, because a squared plus b squared must equal c squared. And 3, remember that when you're looking at these three numbers, the largest number has to be c. Okay? Doesn't matter whether they're written in order or not, the biggest number of the three is your c value. So for instance, down below there you see those three numbers 3, 4, and 5. Okay? 3, 4, and 5. We are going to check to see whether or not that is a Pythagorean triple. Well, for one, we should notice that all three of those numbers are integers, so we meet that requirement. So then the second requirement is we need to check the Pythagorean theorem. So which one of those numbers, you can just tell me in chat. And by the way, remember that the chat is recorded, so I can tell whether or not you're participating. Which of those three numbers, 3, 4, or 5, is your C value? Let's type in the chat. Which one is C? Good. C is 5. Okay, the biggest number there is 5, so that's the C. The other two numbers are your A and your B. So we are going to simply check the Pythagorean theorem. We're asking ourselves, does a squared plus b squared equal c squared? That's what the question mark over the equal sign means. It means we're checking to see whether or not these things are equal. So we plug in our numbers, 3 squared plus 4 squared. Does that equal 5 squared? Well, 3 squared is 9. 4 squared is 16. 5 squared is 25. 9 plus 16 is, in fact, 25. So since this is a true statement, our answer here would be 3, 4, and 5 is a Pythagorean triple. Okay. Yes, that set of numbers is a Pythagorean triple. Okay, so that's the skill we're working with today. Relatively simple idea, but there are a couple places where we can make mistakes that we have to make sure we're taking enough time to not make mistakes. The big one is C is the biggest number, period. Of the three, C is always the biggest one. Okay, the other thing is they have to be integers. If they are decimals or fractions, the answer is automatically a no. That is not a Pythagorean triple. They have to be integers. And the other teachers were concerned that maybe we might be interested in why they have to be integers. Well, that's a historical thing. So the Pythagorean theorem and all the other stuff that falls under that heading is named after a Greek mathematician named Pythagoras. And Pythagoras is famous because he was the first person who is recorded as realizing that these sets of three integers existed that formed right triangles, which revolutionized a lot of things in ancient Greece, specifically architecture. And as a result, his followers kept this information extremely secret. So when we say, why do they have to be integers? They have to be integers because we're naming a set of numbers that we've been working with since ancient Greece, when there really was not much of an understanding of partial numbers. So they really only dealt with integers. Anyway, that is not super important. All we're really doing today is it a Pythagorean triple? Yes or no? So here we go. Let's do a couple examples. So here are two examples on the same page with the same set of directions. Determine if each set of numbers represent a Pythagorean triple. Use words, numbers, and or symbols to justify your answer, which means I expect to see the work. Okay, that's what I'm shooting for there. Okay, there are a couple of you that are really doing your best to not show any work when we do stuff on Google Classroom, when we turn in stuff electronically, and that frankly is not an option. Okay, you need to be showing your work so that I can find your mistakes for two reasons. The biggest one being you want partial credit. You can't get partial credit if you don't show any work. So, starting off with 9, 12, and 15. Again, the big thing here is we need to identify that 15 is the biggest of those three numbers. So 15 has to be our C value. 9 is A, 12 is B. Doesn't matter if you get those reversed. So on the homework, you're going to have blanks to fill in identifying which number is which. Remember that the only one that has to be in a specific spot is 15, has to be C. Then you're going to be asked to check the Pythagorean theorem in a workbox. So we're just going to plug those numbers in. 9 squared plus 12 squared equals 15 squared. Yes or no is the answer that we're looking for here. So we're going to calculate this. 9 squared is 81. 12 squared is 144. 15 squared is 225. Then we add 81 plus 144, which is 225, which makes this a true statement and means the answer to the question is yes, that is a Pythagorean triple. Try part B, get out ahead of me. I'm going to give you about 45 seconds to get ahead. By the way, I'm going to be checking this chat transcript today and any further days where we have to go virtual. When I ask one of these questions and you don't answer, I'm going to assume you're not paying attention, and I'm going to call on you personally and make you talk in front of the entire class. So please make sure you're paying enough attention that you can answer my questions when I ask them. Okay, we need to stay engaged. We need to stay engaged. Again, we should be back in person Monday, which will result in us being able to, frankly, do more, in my opinion. And Monday is also the start of second semester, which will be a nice fresh start to everyone's grades. So, about 20 more seconds, and we will try and finish, see how we do on the second example. I'm sorry to hear that, Shelby. That probably means that the internet, either on my end or your end, is not great. Good news is it's being recorded and it's not cutting out on the recording, judging by the captions coming through. So worst case scenario, the recorded video will be up here later today. But none of that was really super important to the lesson itself. It was just more or less information about the beginning of second semester, which will all be repeated on Monday. Okay. Trying really hard not to be distracted by the colorful flashing lights in the background of the video there. Anyway, let's see how we did. In the chat, tell me which one of those three numbers, 3, 7, or 9, is your C value. Which one of those numbers is your C value? Very good. 9's the biggest. 9 is C. Don't fall into the trap of thinking that the third number will always be C. As you'll see on a later example, that is not the case. A and B, it doesn't matter which one is which. A, in this case, I'm going to say A is 3, B is 7, and C is the one that matters. That is the biggest. That is 9. Then we check, first of all, those are all integers, so we do need to continue the problem. We're checking to see whether or not A squared plus B squared is equal to C squared. So we plug those numbers in and we say 3 squared plus 7 squared. Does that equal 9 squared? 3 times 3 is 9, 7 times 7 is 49, and 9 times 9, well, that's 81. Hopefully everybody in this class can then look at that and go, well, those are definitely not equal. Okay, that is a false statement, which means that this particular set of 3 numbers does not represent the side lengths of a right triangle. It is not a Pythagorean triple. Any questions so far? All right, we are going to put 2 more up there, and I want you to try them. I'm going to give you about a minute, and I'll repeat some more of that information about start of second semester here. Okay, so try these. And while you try these, I'm going to point a couple things out. One, virtual learning has taught us one thing, and that is that in theory, even if we are not in school, we could still sort of be in school. So if you were to be put in quarantine over the next few weeks, which is obviously we're still in the middle of the pandemic, so it could happen, okay? If that happens, you will still be required, assuming that you're not actually too sick to attend, to actually jump into Google Meet during class and watch class, okay? We'll be running these same sort of Google Meets if kids are out, and you'll still be able to watch the lesson, so you won't miss as much while you're out on your quarantine. You guys all have your own Chromebooks. Shouldn't be any big deal to do that. So that's how we're going to be handling that going forward. And each teacher has their own ability to do that. It's up to each teacher whether or not they do. Your geometry course will be cast on Google Meet if people are out of the room. Okay, so if people are home on quarantine, I will be live casting the notes when we do them. Pretty much be the same thing you're seeing now. When we come back Monday, we're starting the second semester. It is fresh. Now, somewhat fresh would be a better way to put it, because the homework from Wednesday and the homework that you're going to get today will both be grades on quarter 3 in second semester. So you will have a couple things in there, but for the most part, we're starting with a completely clean slate. Okay? Good, bad, indifferent, your grade has started over. Everybody's got a nice fresh start to second semester. So if you had fallen behind, you won't be behind anymore because it's brand new. All right. Raise your hand if you need more time. You can do that either on your camera or digitally. Okay. Let's get our answers worked out here. I'll give you about another 45 seconds to a minute. You can just digitally put your hand down when you're ready for me to start going over these. It's been an interesting week here at SHS. Hallways are quiet and everybody's trying to get ready for all of you guys to come back. I spent 45 minutes yesterday putting my room back together. Now all the desks are in my way. Also, at some point, I'm going to have to turn my computer around again, because right now my whole desk is facing into the center of the room. Now, Cooper, you got to remember that all the desks have to be as maximum spaced as possible, so they all have to be in exactly the right place. So it took a while. Okay, we good to go? Anybody need more time? Raise your hand digitally if you need more time. Okay, let's see how we did. In letter A, which number is C? 24, 60, or 45? Tell me in the chat. Which one's the C value? We're typing so fast, we're missing the 6 key. Okay, 60 is correct. 60 is the largest number, so that's your C value. The other two, 24 and 45, are interchangeable. One of those has to be A, the other one has to be B. It does not matter which one is which. Okay, we got our three numbers. They are all integers. So then we go in and we check the Pythagorean theorem. We ask whether or not a squared plus b squared is equal to c squared. So 24 squared plus 45 squared, does that equal 60 squared? Now this is an example of why everyone has been assigned a calculator, because no math teacher, no matter how mean they are, would expect you to know 45 squared without a calculator. Okay, now most of us would expect 24 squared to be a value that you have memorized eventually, but 24 times 24 is 576. 45 times 45 is 2025, and 60 squared is 3,600. Clearly, these two numbers, when added together, are not going to equal 3,600 because it's just going to be just over, 2,600. So that's not going to be big enough. We're looking at 2,601, which is not equal. This is a false statement. So your answer for part A should be no. Raise your hand if you did get that correct. You can either do it digitally or on your camera. Good. Very good. Okay. That's a good sign. All right. On the other one, again, the numbers are not in order. You should have recognized that C was 34. Then you've got 30 and 16 for your other two numbers. Again, those two are interchangeable. So if you said A was 16 and B was 30, you're probably fine. Then we're checking to see whether or not A squared plus B squared is equal to C squared. So that's 30 squared plus 16 squared. Does that equal 34 squared? Well, 30 squared is 900. 16 squared is 256. And 34 squared is 1,156. We then add the 900 and the 256 together. And we find out that that is a true statement. So that answer should be yes. Once again, raise your hand if you digitally raise your hand if you got that correct. Okay. Okay, you can put those down. All right, guys. So hopefully by this point we're in pretty good shape. There are two more examples. We are going to do them because we have plenty of time to do them. Okay. So sounds like we've got a pretty good handle on this, which is a good sign. Does anybody need more time on this slide before I advance the screen? Okay. Go about 30 seconds here, and then we'll change the screen and we'll finish up for the day. We only have one more slide, I think. Now on the homework, it'll be a quiz is. So it's some of the questions on the quiz is, though, are not multiple choice. You have to actually type in an answer. So be prepared for that. And on the multiple choice questions, don't fall into the trap of just clicking, or you'll end up having to probably redo the assignment. It will be, it is available for unlimited tries, so you can try as many times as you want. If you don't like your grade the first time, you can try again, etc. And it will be due on Tuesday. It'll be due on Tuesday because we'll be back in school, so we're going back to the 2 school days to complete the assignment thing. So you'll have the weekend and Monday. It'll be due on Tuesday. All right. One more slide. Same directions. Again, I want you to try these. I'm going to give you about 45 seconds to a minute each. So we'll say here about 90 seconds. I'll check on you, see if you need more time. At most 2 minutes. These should be relatively quick if you have a calculator. You ought to be able to check them pretty quickly. Again, same directions, same work. Do these sets of numbers represent a Pythagorean triple? Some of you on camera look like you could not possibly be more bored. Just saying. It's only third period, folks. God knows how many more classes some of you have today. Okay, give me a raised hand if you need more time. Raised hand if you need more time. Digitally, please, so I can... Oh, okay then. So we're good to go. Everybody's good? Let's finish up then, shall we? 6, 8, and 10. In the chat, tell me which one of those three numbers is C. 6, 8, and 10. Which one is C? See those numbers flying in there as people pay close attention to me. Outstanding. C is 10. Okay, that means A and B are the other two numbers. Again, we are checking to see whether or not these three numbers fulfill the Pythagorean theorem. So 6 squared plus 8 squared, does that equal 10 squared? 36 plus 64 does in fact equal 100. So that is a true statement. You should have yes. Okay, letter B here. Letter B is an example of the so-called trick question version of this problem. If you spent more than 2 seconds on letter B, you might not have gotten it right. The answer to part B is definitely no. Does anybody know why? You don't even need to check the Pythagorean theorem to say no.
The 1.
Yeah, Abby's right.
Oh.
Decimal. Okay. The second you see a decimal, those are not integers. Okay. These two numbers right here are not integers. They are rational numbers, which means the answer automatically is no, because a Pythagorean triple has to consist of 3 integers, and 2 of those 3 numbers are not integers. You know, if you check the Pythagorean theorem here, this is a trick question, because guess what happens when you check the Pythagorean theorem? Actually, I guess it does 6.76, not 6.25. See, the Pythagorean theorem works. But it doesn't matter, because they're not positive integers. It can't be a Pythagorean triple. Those numbers do represent the side lengths of a potential right triangle, but because they're not integers, it is not a Pythagorean triple. Okay? They have to be integers. So don't waste time on a problem if it asks you, is this a Pythagorean triple? And one or more of the numbers are a decimal or a fraction. That's an automatic no, and you don't need to worry about checking the Pythagorean theorem. Okay? So